Printing techniques have been used for centuries to pattern textiles and clothing, but a lot of people don't realise that these techniques have also been used in the electronics industry to manufacture printed circuit boards and so-called hybrid circuits. To print hybrid circuits, we use functional electronic materials that behave like conductors and resistors. Hybrid devices are typically printed on rigid ceramic substrates that won't flex. It would be great if we could also print these types of electronic materials onto textiles to create flexible, wearable electronics. I'm Steve Beebe, a professor in the Department of Electronics and Computer Science at the University of Southampton, and I'm going to tell you about a platform technology we've developed that enables functional electronic materials to be printed on textiles. Textiles are challenging because of their surface roughness, their fluffy nature, and because we have to be careful not to heat them up too much during the curing part of the process. We've overcome these challenges by developing a suite of printable inks specifically for textile applications. Key to our technology is the development of flexible interface and encapsulation inks that smooth the textile surface and protect the printed active layers, enabling them to cope with normal wear and tear and activities like washing. The functional inks that can be combined with these films can act as far more than just electrical interconnects. For example, we've made carbon electrodes for medical sensing applications like ECG, strain sensors out of our piezo-resistive inks, and we've created piezoelectric inks for actuation and sensing applications. We've even created electroluminescent inks that can emit light. Our spinout, called Smart Fabric Inks Limited, supplies these functional materials to our customers and also uses our technologies to create complete functional textile systems. We've made everything from electrode arrays for functional electrical stimulation in medical applications to an electroluminescent textile watch. The screen printing process involves applying the inks to the surface of a patterned screen. The screen is made up of a mesh and the pattern defines the open areas through which the ink can flow. A rubber squeegee pushes the ink through the screen and onto the substrate, and in this way the ink is deposited in the pattern required and no subsequent photolithography or etching is necessary. The films are cured at high temperature or with UV light, and layers of different materials can easily be built up, resulting in the complete flexible electronic textile. One application of the technology is printed dry electrodes for functional electrical stimulation, or FES, which is used for patient rehabilitation. FES uses controlled electrical signals applied through the printed electrodes to assist the patient in performing activities of daily living, such as picking up objects. The fabric electrode array provides a comfortable, wearable solution and more precise FES control, which speeds up recovery times and improves patient outcomes. Smart Fabric Inks is an exciting spin-out offering a comprehensive platform technology for electronic textiles. We have a broad portfolio of functional materials and the expertise to develop new solutions. We're looking for partners who would like to develop textile systems that exploit our technology. So if you're interested in developing wearable sensors and devices using a straightforward, low-cost printing process, please get in touch.